Now we'll solve a second problem on indeterminate beam using stiffness method. So as we said earlier, first of all, we will find the fixed end moment. For that, we will consider these two supports as fixed end, and we will find our fixed end moments. Fixed ends, two supports, and so this is point A, B, and C, and the loading as it is, and a point load of 12, and this is of 4. So now we'll get fixed end moments. So for this UDL, we'll get a moment of 4 multiplied by the span length, which is 16 squared over 12, which is 85.33 feet, and its direction will be this way. So this is 85.33 feet. This is 85.3. Oh God, 85.33 feet. And for the point load here, we'll get a UDL here and here. We'll find the values. We'll get a value of for this point 12 multiplied by 8 multiplied by 6 squared over 14 squared span length. That will be 17.63, and for this one it will be 12 multiplied by 8 squared multiplied by 6 over 14 squared. The value will be here 23.51. 23.51, and here the value will be 17.63. These are our fixed end moments. You will get reactions as well, but for this problem we will not draw the reactions. Later we'll introduce our doki, but before that we'll have to find out how many dokis are possible here. So here you can see there can be no doki applied here, but here one doki can be applied at point B, and one doki can be applied at point C, and the doki is rotation. Let's say we'll apply rotation U1 and apply rotation C as U2. So U1 is equal to 1 and U2 is equal to 1. These are the dokis we'll apply, one rotation and one rotation. Let's go to the next page. Here is our frame, and here is our supports, and here is our supports. But at point B, if we apply doki anti-clockwise, it will be something like that, and the shape will be something here. There will not remain any deflection. It will be something like that, and here it will be something like that, and here it will be 90 degree. So the shape will be something like that. It will connect this line. So here the doki is for u1 is equal to 1 radian rotation. So here we will get 4 moments. Yeah, here the moments are this moment, this moment, this moment, and this moment. The moments are for Doki E1, and for this it will be 4E, and it is actually twice I, twice I. So it will be, sorry, so it will be 4E twice I over the length. The length was 16 feet, and for this it will be 4E simply I over 14. The span was 14, and and at this point A, it will be half of this. That will be twice E twice I over 16, and at point this it will be half of this, which is sorry, twice E I over 14. These are the possible moments which are generated for the application of Doki U1 is equal to 1 and U2 is equal to 0. And now we'll apply the Doki U2 is equal to 1 and U1 is equal to 0. For that, we'll draw the frame again. So now the Doki will be applied at point C, this point C. So for that, we'll see that a Doki, like something like that U2, it will make the shape like this, and this will generate a shape like up to this point. Up to this point, it will be something like that, and it will be something like that because the joints are fixed, so there will not be any rotation near support. And for a anti-clockwise rotation, it will come downward a bit, and here it will be like that, and there will not be any moments at this point and at this point, at this point and at this point. There will not be any moments because the Doki was here. So for the moment here, we got a like half of this moment here, but and for the first case, the Doki was here, so we got a half of the moments here and half of the moments here. But here we got the moment, and we'll get half of the moment here, not here and here. So it will be it will be 4 E I over 14 multiplied by u2. So it everything it was u1, u1. I missed the u1, and here it will be, sorry, twice ei over 14 u2. So it was for u1 is equal to 0 and u2 is equal to 1 radian. So these are the moments we get for the application of Tokis. Now we will make two simultaneous equation so that we can solve for U1 and U2. We will apply the equilibrium formula at point A, B and C, because at these 2 points we applied our Toki. So now we'll form our simultaneous equation. Say we know that the moment internal, sorry, first of all I will say external, the moment external is equal to the moment summation of moment internal. Here there was no external moment. Say for say for point B, say at point B there was no external moment, so it was actually 0. So, was there any internal moments? Yeah, there was internal moments for fixed end at point B. The internal moments is 85.33, either is clockwise so negative, and 17.60 anti-clockwise, so this is positive, and few other moments, these these these. So 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 five moments at point B. So first of all, the moment is 85.33, if I'm not wrong. Yeah, 85.33, negative 85.33. Negative 85.33. Later we'll get 17.63 positive. Later we'll get what do we wrote here? It is 4 multiplied by 2, 8 ei over 16. 8 ei over 16 u1, and this, which is twice ei over 14 u2. So this is our, say, first equation. We'll make another equation, let's say, for point C. So at point C there was no external moments, but what were the internal moments? We had internal moments of 23.51, it is clockwise so negative, so negative 23.51. And at point C we had two other moments for the application of Doki, which is plus twice e I u1 over 14 plus 4 ei over 14 multiplied by u2. So these are the moments we got for the application of Doki. So these are our two equilibrium equations. So now you can use calculator, and you can take, let's say, while you're using calculator, you can say u sorry ei u1, let's say it is x, and ei u2, let's say y. So you can put these two equation in calculator, and you can find the values of u1 as, so after solving, u1 as 78.32332 over ei, and u2 as 43.135 over e1. Once again, I'm saying you'll go to your calculator. You have x and y's, and you have, say, constant. So in your x, you will have 8 over 16 ei, 8 over 16 ei. But you'll let's say this is your x, so just 8 over 16, and this is your y2, so it is actually 2 over 14. And for constant part, you have this part. And for this equation, second equation, you have a little bit of space. You have actually this, which is 2 over 14, which is 2 over 14, and you have 4 over 14, 4 over 14, and you have this constant here. So you can solve this equation. Here it is actually minus 80, sorry, plus 85.33 minus 17.63. You have another constant which is 23.51. You can solve the equation in calculator. You will get the value 78.323. You will divide it by ei, so you will get e1, and you will get another value 43.1235. You will divide by ei, you will get u2. So these are our dokis. So after getting the dokis, we'll find our values of, say, moment. Say we want to find the moments of, say, moment, say, at point B in the direction of C, this moment. So For that, we'll need our equation. C, we'll superimpose our moments. At point B, to the duration of C, we have the moment 17.63, which is anticlockwise, hence positive. 17.63, 17.63. Later, what do we need? We need the door keys, B to C. We'll use this value, 4ei over 14 u1. 4ei over 14 u1. What is our u1? u1 is 78 multiplied by 323 divided by ei. Another doki what we have here is this, 2ei over 14 u2 plus 2ei over 14 u2. What is our u2? Our u2 is 43.1235 over ei. After solving, yeah, it will actually vanish this and this and this. After solving, you will get a value of 46.1, sorry, 46.161685 cubic feet. You can find out the reaction as well. Let's say you want to find the reaction BC. For that, what you need is actually your B point. B point. For B point, you have a moment like this. So you get a reaction of, say, a point. I have a calculated value of A. Well, for A, I will show a reaction of, say, you have a UDL. So for that, you will get a reaction like this, which is actually 4 multiplied by 16 divided by 2, which is 32. Okay, which is 32. So 32. Later, we'll get two other values for the application of Doki. So for the application of Doki E1, you will get a reaction here as well. It will, you'll get a reaction and say it is giving a kind of like this kind of moment. So it is trying to like compress this restraint. So you'll get an upward reaction of 6 ei. I was twice I over L squared. Here the L was 16 squared multiplied by the ui. The u1 was 70, if I'm not wrong, 78.323 over ei. And you can find out the value. So you can apply this well. And for Doki 2, U2, you'll not get any reaction here. So at point RA, you will get a value of like this. Sorry, I'm trying to find out RA. So you'll get a like 6E twice I over 16 squared multiplied by 78.323 over EI. After calculating, you will get a value of 35.673. You can find the reaction and moments of other points as well. I pre-calculated all these values, so I'm showing it so swiftly. So you can find all the values. So this is all from the problem 2. We'll maybe see another problem on beam, then later we'll shift in frame problem.